Yeah. Okay, so picking up where we left off. We went through the inner planets. We ended up getting to Mars, and I just very briefly talked about Mars. So let me add a few more topics about Mars before we go to the outer planets. Mars is the last of our 4 rocky planets, the inner planets. It's about half the size of the Earth. It has a weak atmosphere. That is, there is an atmosphere, but it's about 1/100th as thick as our atmosphere. And it's only 0.15% oxygen. Even if it was fully oxygen, it wouldn't be. Here, Candace. Candace. Here's your test and the last time you were here when I passed them out. So that's 2. Okay. So even if it was 100% oxygen, it wouldn't be enough. But we talked about how it could be modified, because if it could have an atmosphere, it would be in a zone that we would consider habitable. Now we're going to move beyond Mars. Beyond Mars, the next thing you come to in the solar system is what we call the asteroid belt. Now, asteroids are later in the lecture, but let me just bring them up right here. Asteroids are basically rocks. So the asteroid belt is a belt of rocks that's between Mars and Jupiter. If you've watched movies like, let's say, Star Wars, you have them flying through an asteroid belt. And how do they fly through an asteroid belt?
Like dodging everything.
Like dodging everything. That is very, very far from realistic. The asteroid belt is still mostly empty space. You would just go cruising by, maybe veer a little bit every now and then. Right? So it's not this big density of chunks. But it is accurate that it's a bunch of rocks. The rocks come in a couple different varieties. Some that are more iron rocks, some that are more silicate type rocks. And if you were to combine all of those rocks together, you would have a mass that's far less than the mass of any planet. So it's not like it's bigger than a planet just all broken up into pieces. If you combine them all together, it'd still be much smaller. In fact, the vast majority of the mass of the asteroid belt is in one asteroid series. And so we'll get to minor planets. The Ceres is a minor planet or a dwarf planet. Out beyond there, you're past the frost line. The frost line being that line where you could have things that are volatile that have a low melting temperature could condense, and thus you could grab a lot more of the gas. And so these are all very large. They have lots of gas. So they're very different from our Earth and the rocky planets, but they do all have a rock at the center, a big rock at the center. So basically, it's like Earth or Mars or Jupiter, except for it grabbed a bunch of gas along with the stuff that we grab. So that just makes it so it has a lot more stuff plus the stuff we have. So let's look at Jupiter. Could have sworn I had a picture of Jupiter here. There it is. I knew I had a picture. So Jupiter is the first of the gassy planets. It's by far the largest of our planets. Jupiter has 11 times the Earth's diameter. I can't actually remember its mass, which I know is sad, but it's much more massive than us. It's somewhere around 70% of the planetary mass is in Jupiter. And the vast preponderance of what remains is in Saturn. More liquid than gaseous or solid. What is the exterior of Jupiter? It's a gas. But as you go down, it gets thicker until you would say, that's a liquid, even though you never have the splash. I talked about that. And this is where you have the liquid metallic hydrogen occurring. Not in the sun, like I started to say, I guess it was last class period. But in Jupiter and Saturn, that's where you have liquid metallic hydrogen, and that's what we believe makes their very, very strong magnetic fields. Notice the atmospheric pressure, 1,000,000 times that of the Earth's. Here's a question: where do you measure the atmospheric pressure on Jupiter? I really don't know myself, because it has no surface, so to speak. what we see as the surface is not a solid surface, just like on the sun, what we see as a surface is not a solid surface. On the sun, what we see as a surface, we call the photosphere, is a very thin region where it goes from light is absorbed to light is not absorbed. That's what we see as the surface. So when we look at Jupiter, it's a similar thing. It's where the gas gets to a certain, thickness where light can travel through. That's what we see as the surface. If you were actually there, at the quote surface, you'd say, but this is just wispy gas. This is like being in a cloud. It's not the surface. So when we look at Jupiter, all of this stuff is gas, except for that, and I am pretty sure this is a moon also in front of it. Those are moons, different things, yes.
Like theoretically, you could like fly into Jupiter, and you just keep going until you hit the center.
Well, you would face more and more resistance. Think about this: you're driving in your car. Now, if you were in a vacuum, if there was no air, you put your hand out the window, there'd be no resistance, right? But because there's air, there's resistance on your hand. And if you went from air to something that was thicker air, it'd be more resistance. So that if it keeps getting thicker to where you're going through water, that'd be a whole lot more resistance. So that's what not just would happen, has happened. We have sent a probe that went into the atmosphere of Jupiter. And as it goes in, it receives a lot of air resistance. So it had a heat shield that was burned away and finally it was destroyed. And what they were doing was measuring the gases in the atmosphere. And what they found was a lot less water than the theories had predicted. So we've been talking a lot about the scientific method and how we come up with hypotheses and how we test them. And that was a direct test. And the direct test said a lot less water. So what does the scientist do when you do the direct test and it says a lot less water?
Change hypothesis?
Yeah, you have now evidence that your hypothesis is wrong. Now, the scientists saw there were two options. Number one is maybe we were extremely unlucky and we just happened to hit a region that's drier than most, or maybe we were wrong. And so then they have to go back and reevaluate and try to come up with a better understanding of what's going on there. Now, you see this thing right here? It's a great red spot. Pretty shocking how scientists come up with these names sometimes. That great red spot is a cyclonic storm. It's like having a tornado that's been going on for at least 300 years. That was there when Galileo observed Jupiter, and it's still there now. Now you can see there are lots of other spots like that on the surface. You have some that are white, some that are dark. Those are all cyclonic storms. And you have winds, very high winds, that are going opposite directions of each other. And so at the boundaries of those, of course, you're going to have significant storms because you have winds going opposite directions. And so these storms, like this, like these three here, they tend to form on those boundaries where the winds are going opposite ways. Very high-speed winds on Jupiter. Its atmosphere, 82% hydrogen. Why do you suppose its atmosphere is mostly hydrogen? Go ahead, Brittany. What was your answer? Don't know. Well, once again, just like the sun is mostly hydrogen, because hydrogen is the major component of the universe. And so since this formed out there where it could collect all kinds of gases, hydrogen being the most common gas, that's what it collected the most of. And then you have helium that's next, because helium is the second most common gas by a big margin. And then you have 1% of lesser things. It has a solid core, like I said. They believe it's iron and nickel and other elements. How do they know? Well, we've never been to our core. Certainly we've never done any actual excavation of the core of Jupiter. But by using their models, they believe that it must have collected, these heavier metals like the Earth did, and they should have differentiated and sunk to the center. It has a thick atmosphere, and hence the temperatures are pretty much the same everywhere on the planet because the atmosphere is moving that heat around. 4 largest moons of Jupiter are called the Galilean moons because Galileo Galilei, when he first got a hold of a telescope, or he didn't invent the telescope, but he heard about the telescope invented by these gentlemen from the Netherlands. He tried to buy one, but they were gone, so he followed other people's descriptions to make his own. And he improved the quality of telescopes. And he was the first one to systematically use them to stay in the sky. And he saw 4 things that were orbiting around Jupiter. That was really important to developing our understanding of the Earth not being the center of the universe, because here you had things going around Jupiter, and they thought everything had to be going around the Earth. So these are very distinctly different objects. If you look at Io, that is a rotten egg of a moon. It has sulfur volcanoes. Wouldn't want to live there, right? What makes the volcanoes? It has to have something that's causing energy for it to have a volcano. And what causes it is Io is so close to Jupiter that the gravitational force on Jupiter causes quite a bit of flex. And Europa and Ganymede coming around will cause additional flexing. And so it's constantly being bent. And so it's just like taking a piece of wire and bending it, and it gets hot. That's what's going on with this moon, making it so it's hot enough to have these sulfur volcanoes. Question?
What makes a moon?
What makes a moon a moon? Okay. Start with basic things. A moon is not a planet, right? A planet is something that's orbiting the sun, and we'll get to its definition later. A moon is something that's orbiting a planet. Gravity is what's holding that moon to the planet, just like gravity is what's holding the planets to the sun. And so it's something that got close enough to a planet for the planet's gravity to grab a hold of it and keep it going around the planet.
So technically, like, say, like, some meteor was like, oh, I want to go towards the Earth, but the Earth's like, no, you're just going to start revolving around me. You can have another moon.
That's correct. And it's believed, not our moon, but it's believed that like the 2 moons of Mars, that's how they came to be there. Most of the moons of Jupiter is known to have somewhere in the ballpark of 70-ish moons. Most of those are believed to be exactly what you just posited. The big ones probably were forming up, same time that the planets were. Probably. When we get to the Earth's moon, we'll talk about it a little more carefully. You have to follow up?
So how is it that, okay, so if Jupiter's gravitational force is so strong, how is it that other moons can pass Jupiter and go further to like Earth?
If they're going fast enough or they're far enough away, they have enough energy to get away. So it depends on how close they pass and how fast they pass. Yeah.
Never mind.
Okay. These 3 here, those have icy surfaces. In fact, if you look at that picture of Europa and you didn't know better, it would look like one of the pictures they just took of Pluto. Right? Have you seen the pictures of Pluto with the looks like a heart, that's the reddish stuff? Looks a lot like that picture of Europa. These have ice exteriors. And this one, Europa, and actually to a lesser extent Ganymede, have, they believe, liquid water floating underneath there. And so scientists believe that you could conceivably have life on Europa. That is, you have this ice covering, you have a sea, and then you have oceans that will have mid-oceanic rifts, just like the Earth does, that would vent hot material, giving you a source of energy in a water-rich environment, and they hypothesize you might have conditions for life to exist there. Now, because of that, scientists hope that someday they can send an explorer to explore Europa to look for life. And so that's why with our satellites that we sent to explore Jupiter, they want to make sure that nothing from those satellites ever made to Europa, because then they could, once again, plant life. You come back and you just discover the life you brought there, and it's not very exciting. You want to make sure that it's pristine. And so they intentionally crashed their probe, recently, it's now a few years back, into Jupiter so that it wouldn't end up randomly crashing into Europa. Getting on to Saturn. Saturn is a lot like Jupiter. Now, if you look at this picture, you can just barely see that it has these belts on it. It has the same kind of weather patterns that we call them belt zone weather patterns with high-speed winds as Jupiter. But the difference is that its atmosphere, its upper atmosphere is not as transparent, so you can't see those as well. But what's the obvious feature of Saturn? The rings. Now, Saturn is not the only planet with rings. All of the planets that are gassy planets have rings. So Jupiter, Saturn, Uranus, and Neptune, they all have rings. But Saturn's rings are different. Saturn is the only one that has icy rings. So how do these rings form? We go back to the question that Brittany asked about how are moons formed. These rings are believed to be formed by things that came too close to the planet, and the tidal forces, the difference in the force of gravity here compared to here, were strong enough that they actually shredded the objects. So for Saturn to have icy rings, you had to have something that's largely ice, that would be a comet, that came too close and got shredded by the gravity of Saturn to make those rings. Now, of course, those rings can't last forever. Those rings, from collisions and whatnot, they're going to slowly lose energy, fall in, and just become part of Saturn. So the rings are transitory. Now, of course, as a creationist, I pay a lot of attention to creationist arguments. And some people argue, the lifetime of a ring like the rings around Saturn is, not all that long, measured in hundreds of thousands of years or less. So that means Saturn can't be older than that. There's a logical flaw there. What's the logical flaw? Yeah, just because the rings weren't there doesn't mean the planet wasn't there. They're presuming that it had to have been created with these rings and then they're going to disappear over time, and not allowing for the chance that these rings might have naturally occurred. And so scientists believe these naturally occurred from a comet coming too close, and scientists say, no, that only means that the comet came too close sometime fairly recently. Now, if you look at the other three gassy planets, Jupiter, Uranus, and Neptune, their rings are very, very different. Right? You've never seen them in pictures, probably. Indicates they're very different. Their rings tend to be more like little pieces of dirt, or maybe like smoke. Different in composition. And the theory is their rings were probably, instead of a comet, something that was more of an asteroid that got too close and got shredded by gravity. So same process, but different type of object, giving you different type of material for the ring. And their rings are very, very thin, meaning they're just really old and pretty much have deteriorated. Saturn has its largest moon, Titan, which I believe was in the news just these past couple weeks. I think it was Titan where they were saying there might be life. I get Titan and Triton confused, sadly. Triton is the major moon for Neptune. Titan is the major moon for Saturn. But it has its own moon that was visited by the Cassini spacecraft that's a major moon. Uranus is super interesting, not just because its discovery is interesting in and of itself. When it was discovered, the first person to find it just ignored it. Second person to find it wanted to call it, King George's star, like Georgius Siderius. But by convention, the planets have to be named after gods. And so that was rejected, and it was named Uranus after God. And you can pronounce it Uranus or Uranus. Neither one is free from childish jokes. I choose Uranus because it seems to be less free from childish jokes. Its tilt is what makes it really interesting. About a 98-degree tilt. 90 degrees would be going around the sun with its axis so that at some point the sun's pointing directly at the North Pole and at some time directly at the South Pole. It's only 8 degrees away from it, so it has crazy big temperature swings, or not temperature swings, but seasonal swings, because it's tilted so much. Like I said, it has a faint ring system, a methane atmosphere. It gets its color based on the amount of methane. Really cold. Right here, oh, come on, it disappeared. Right there, you have a great blue spot. Yeah. You guys are getting into this scientific naming convention thing. It's just like the great red spot. It's a cyclonic storm again. And if I remember right, that blue spot has disappeared. The storm has ended. Yay, if you were there. Neptune. This shows some rings for Neptune. I don't know if you can even see them from there, but there you can see some rings for Neptune. Actually, maybe it was Neptune with the great blue spot because that one looks better. Neptune is the first predicted planet. People looked at the orbit of Uranus and they said, it's got some wobbles on it that shouldn't be there. But they could be explained if there was another massive object that was coming around and pulling it in and out and causing deviations. And so based on those wobbles, they went looking and they said, okay, this is where it should be. This is, what spirit should be. They went looking and they found Neptune. A great success. And so we have Neptune, another big icy object, well, icy and watery. Neptune and Uranus both have really bizarre magnetic fields. The magnetic fields are tilted quite a bit from their axes. The Earth, we have a north geological pole or geographic pole, and the north pole for a magnet, the north pole for magnets is actually the south pole. The south magnetic pole of the Earth is really close to the north pole of the Earth. It's not at it, but it's close. With Uranus and Neptune, they're not even going through the center of the planet. Their magnetic fields are off to the side of the planet. So the planet's like this, and they're off like that, and not pointing close to the pole. And so scientists are, how could that occur? And their conclusion is, unlike we believe Saturn and Jupiter have this liquid metallic hydrogen swirling about, that you must have a mixture of like salt water and ice. And because of the ice, the water is not doing nice, smooth flowing. And that's what causes the real wonky behavior of the magnetic fields of these two planets. Notice it says a highly elongated elliptical path. That means it's eccentric. It's not circular. So Neptune is not as circular as the rest of the planetary orbits. Mercury and Neptune, not as circular. The rest of them very close to circular. Now, after discovering Neptune, scientists observed the orbit of Neptune and said, that's still not right. There must be something more. And so they predicted another planet, predicted its location, and went looking, and they found something. And what did they name that thing they found? Pluto. Now, something you probably have never connected, if you look back here at the periodic table, the last naturally occurring element, what's its name? Uranium. Named after Uranus. And then the first man-made element, Neptune. The second man-made element, plutonium. Now it ends there. There's not a predicted planet of America, or a predicted planet of Curie, or of Berkeley or California, or going on. But there is a matching there between the last one that was found naturally, and then the ones that were predicted, and man was involved. Now we didn't create Neptune and Uranus, Neptune and Pluto, but they were predicted and then found. So Pluto was called a planet, but you know what they instantly discovered? It didn't have any of the qualities necessary to cause the deviation. It wasn't the droid they were looking for. It wasn't the planet they thought that they were looking to find. But because it's been predicted, they called it a planet, and everybody was happy until 2006. And in 2006, I've got two questions here. I'm going to finish this up before I ask those questions. In 2006, scientists finally had enough. And they said, we are going to define planets so Pluto ain't one. So we're going to come up and we're going to talk about those. But first we have some clicker questions. I have said the answers to these two, but you may not have picked up on all of them. Select all the planets that have moons. So you put in all of the planets that have moons and hit enter. Still missing Skyla, Jocelyn, and Raquel. Just one. Okay. Now our answers here: 2, 3, 15, 11, 15, 14, 10, 6. Now I am really, really confused about the two people who said Earth does not have a moon.
I told you.
That seems a little astounding to me. The Earth has a moon. You can look up on most nights and see it in the sky. The Earth has one moon. We'll call that moon Luna. It has a lot of different names. Mars has 2 moons. I mentioned those earlier in the lecture. I didn't give you their names, though. Phobos and Deimos. What does Phobos mean?
Fear.
Fear. Deimos?
God.
Terror.
What? Oh, wow.
They're twins, I think. So fear and terror, those are the moons of Mars. Jupiter, we looked at the 4 Galilean moons, but it has lots of other smaller ones that were probably asteroids that it collected over time. Saturn has one big one, lots of smaller asteroids it collected. Uranus, I don't recall any big moons of Uranus, but lots of smaller ones. Neptune has the one larger one, Triton, and a bunch of smaller ones. So everything from here down has moons. Only the 2 innermost planets, Mercury and Venus, don't have moons. You could probably come up with some kind of hypothesis to explain why, right? That's an interesting thing. Why suppose they don't have them?
The sun burns them.
Well, probably not burn them away, but it's got to have something to do with the sun, right? Yeah, maybe the sun's gravitational pull is so strong that the others, the planets just couldn't hold on to them there. Don't think so. Let's move away from that one and move on with the lecture because we've got to get to Brandon. We only got a few minutes, 20 minutes to get to Brandon. So now another follow-up question. Select all the planets that have rings.
Saturn, everybody. Throwing that out there.
Skyla and Raquel. Okay. Okay, so somebody tell me about the rings around the Earth.
Wait. Oh, just kidding. Never mind.
There's no rings around the Earth.
What? I see what Who's responsible for this?
Oh, Jupiter does?
There are rings around all of the gassy planets.
Oh,
The three, Jupiter, Neptune, and Uranus, have very thin rings that you can't see except for special conditions with backlighting. Saturn has ice rings that are big that you can easily see with the sunlight shining on them. And I'm glad to see, at least this time, everybody agreed that Saturn has rings. We're doing better. Yes?
Would it be possible to land some kind of spacecraft on Saturn?
The biggest chunks are maybe the size of a house. And so I would suppose in theory you could put something on something the size of a house. You're probably going to jostle it quite a bit and move it out of position. But in theory you could put something on something that size. The smallest ones are little tiny flakes. Of course you couldn't land on that. And they have had spacecraft travel through the thin regions where it looks like there's nothing. And they actually just turned on a sensor to detect all the collisions, and you just hear it go, and then lots of collisions, and then less as you go through. It's kind of landing on it. It was a bunch of stuff landing on the spacecraft. Okay, now talking about Pluto. 2006, it got demoted to cloud category, a new category that was made up for Pluto. Somebody over here turned in a question in the last class period that said, is Pluto a planet? And the answers were yes, 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 or yes. Well, so the answer is no, of course. Pluto's not a planet. But they made up a category, dwarf planets, to appease the people who love Pluto. So why is Pluto not a planet? Let me count the ways. Number one, the original definition of planet, which I actually put on the next slide. Planets were called planets because it's Greek for wanderers. As ancient astronomers looked in the sky, they saw the stars are all moving around the Earth like this. Of course, we now understand it's the Earth rotating, but they thought the stars were moving around the Earth like this. But there were a few things that didn't move with everything else. They said they wandered with respect to the stars. And so they called them the wanderers, the planets. So the planets were things that you could see in the sky that didn't move with the stars. Well, Pluto, you clearly can't see in the sky, right? It's way too small and far away for us to see in the sky. Going further, if you look at the planets, all of the planets have one thing in common. They've got a big rock at their core. A big rock that's bigger than Pluto at their core. The outer planets have a lot of gas and liquid. Saturn actually has a density that's lower than the density of water. Saturn, if you could make a bathtub big enough to hold Saturn, it would float in water. Of course you couldn't, so it's a silly thing to say. But Saturn has a lower density than water. Those gassy planets have densities that are less than 2 grams per centimeter cubed. The rocky planets have densities that are greater than 3 grams per centimeter cubed. And Pluto's in between. Pluto is like half ice, half rock, or something like that. So it's not the same type of thing as the other planets. And the final nail in the coffin of Pluto the planet is that there are lots of objects like Pluto. It's not unique. If we start counting all the objects like Pluto, we're going to have a very large number of planets. And so that's not going to work. Pluto's not even the largest of its own type of object. And so they set a rule to separate them and make it so Pluto didn't qualify. I mean, really, the rule is designed to make Pluto not qualify. Just a couple other things. Pluto's orbit is highly eccentric. Sometimes it will be closer to the Earth than Neptune. Sometimes it will be much farther. It spends most of its time farther from the Earth than Neptune. It's in a region we call the Kuiper Belt. The Kuiper Belt is a region with a whole bunch of objects like Pluto. Pluto is a large one, not the largest. Most of them are much smaller, but it's not unique. So now there are 3 things something has to have to be a planet. It has to, number 1, orbit the sun and not orbit some other object. So a moon automatically is not a planet. Number two, it has to have enough gravity, enough mass for gravity to form it into a roughly spherical shape. Now, if you look at something like Saturn, Saturn is the least spherical of all the planets. Why? A, it spins fast, and B, it's got that big ring that makes it so it's fat around the waistline. But it has to be roughly spherical. And then three, it has to dominate its orbit. By dominate its orbit, we mean that it's cleared out other objects of reasonable mass. So if you take the mass of the planet and compare it to the mass of everything else that's orbiting in the same orbit as it, the mass of the planet has to be way higher than the mass of the other things. Pluto doesn't have that. In fact, Pluto's major moon, Charon, is like 1/3 its mass. So when they were having this discussion, some people said, okay, how about this? How about this? Let's make Pluto and Charon a double planet. We'll count them together as one thing, and then that one thing will have, more likelihood of dominating its orbit. But that didn't fly. Pluto is actually known to have, I think it's 4 other moons. Nix, Hydra, I can't remember them all. So this dwarf planet category currently has 5 members. There are other members that should be part of it but haven't been put in it yet. Things like Quaoar. Quaoar probably should be a minor planet, but it hasn't been added to or a dwarf planet, hasn't been added to those. So these here, the top 4, Eris, Pluto, Makemake, and Haumea, those are all objects just like Pluto. Eris is the largest of them. I think I put them in order of size. I might have Haumea and Makemake in opposite order. Ceres is a completely different type of object. Ceres is an asteroid. It's an asteroid in the asteroid belt between Mars and Jupiter. It has enough mass that it's formed into a spherical shape, and it is by far the largest of the asteroids, but there's lots of other objects, so it doesn't dominate its orbit. It doesn't qualify as being a planet. So these things here, the dwarf planets, don't dominate their regions. That's why they're dwarf planets. Okay, the Earth's moon, we are just about ready. Be on your toes. The Earth's moon is a lot like Mercury. It's what we know the most about because it's nearby. We have sent humans have walked on the moon. No humans have walked on Mars. No humans have walked on Venus. No humans are probably ever going to walk on Venus or Mercury for that matter. We sent spacecraft to observe and study all the planets. We haven't studied Neptune and Uranus very well. But we've studied Mercury recently, Pluto recently, studied all of them, but nothing do we know like the moon. Now, the moon has no atmosphere. You had a homework question about what would happen on the Earth if there was no water. If there was no water, would there be weather? The answer, yes, there'd be weather. But if there's no atmosphere, well, you can't have weather because weather is an atmospheric effect. So the moon, having no atmosphere, has no weather. It's always, if the sun's shining, it's hot. If the sun is not, it's cold. Simple as that. Astronauts have been on there. Here's a picture of Buzz Aldrin, the good old US of A flag. See how it waves in the breeze? Thank you for laughing and not taking me seriously. It was folded. These are creases from the folds. It has a rod holding it out here. It's not flapping in the breeze. There have been many conspiracy theorists who say, look, it's flapping. And furthermore, when they put this in the ground, the thing went thingy, and they say, look, see that flutter? But yeah, it's not. There are lots of arguments, people will make, let me not disparage them by saying they're conspiracy theorists, but people will make about why they believe this was all done in Hollywood. Some of them are ridiculous, and some of them take some thought. I certainly believe that man has indeed walked on the moon. And how did the moon come to exist? We talked about, Brittany was talking about how could you collect a moon? Well, the Earth's moon is believed to be the result of a collision. This is not the first hypothesis about how the moon occurred. Hypotheses included maybe the moon formed with the Earth. They just formed or orbited each other from the beginning of time. Or another hypothesis is the moon came flying by too close and was captured. But we have certain things like the crust of the moon is very similar to the crust of the Earth in composition, suggesting a common source for that crust. The moon has less core percentage-wise than would be expected, which leads to the hypothesis that the Earth was here in all of its coolness, just hanging out, and a big object hit the Earth. That big object that hit the Earth caused a whole bunch of debris to fly away from the Earth and form a ring. So the theory is the Earth used to have a ring, and then that ring coalesced to form the moon. So it does not have a ring now. You guys are. So that's our theory on how the moon occurred, that it was, or began, because there was a collision, something hitting the Earth, and a bunch of the surface of the Earth, plus obviously some of the stuff that hit it, went flying out in space, was orbiting the Earth, stuck together, and became the moon. So a clicker question, and when this is done, Brandon's going to come up and lead us. For the rest of the class period, that. You just answer normally, right, Valerie? You just answer normally. Just press the button and it put it in, right? Okay. Let's make sure. It's been a long time with no answers. I was worried that something was not functioning. Okay, waiting on Hannah, Brandon, Carmen, and Raquel. Hannah and Carmen. Okay, you've answered enough that you're going to get credit. So, and so everyone that can answer is 1, 0, 4, 2, and 9. Now, Brandon, come on up. Tell the class how this thing works.
Okay. Yeah, this is great.
You got the flashlight.
All right. So for this demonstration, we're going to pretend that this globe right here is the moon, okay? And my handy dandy flashlights will act as the sun, okay? So we know that we see the moon because the sun reflects light off of it, right? Right, that makes sense?
Yeah.
So we'll pretend that the sun is shining on the moon, right? And you guys are going to pretend like you're on Earth watching this, okay?
It's a stretch.
Right. So, as the sun, I'm sorry if I'm blocking anybody, but as the sun is shining on the moon, we can see like most of its face here, right? Like if we're on Earth, we can see all this, right? Does that make sense?
Yes.
Okay. So, and we know that, I forgot to say, like in this demonstration, we're going to pretend that the sun is moving around, but we know that the sun doesn't move very much. So, as the light is moved, different parts of the moon are illuminated. Do you see how like the shadow is moving? So like this is how like we get our phases. So like as the moon travels around the sun, different parts get illuminated, and we see those different parts illuminated on Earth. Right?
Yeah.
Is this making sense?
Yeah.
So like for instance, if the entire moon is illuminated, which phase of the moon would that be? Right? And if I were to move a little bit over here, and only a little sliver of it is illuminated,
Brady knows your astronomy
still. Or like a crescent, right?
Well, at this point, it's what Brittany said, a wax, or well, it's not necessarily waxing or laying.
Right. But then like as we move like that, it's like a half moon, right? That makes sense? And then like if I were to go to the back, it'd be yeah, exactly. So I guess we can leave it up. So now I'm gonna show you guys how eclipses happen with my handy dandy assistant.
We call me Vanna.
Yes. So So this is just so you guys can see it. So as we know, the moon orbits around the Earth.
So now this is the Earth. This is the moon.
Exactly. Yeah, we switched up a little bit. So the orbit of the Earth it generally goes like this. Like it's like up on one side and it goes down like that. And
The orbit
so,
of the moon around the Earth.
right? And so the majority of the time, the moon is either above or it's below. That make sense? Okay. So, but sometimes the moon gets like to this position. And when it gets to that position, it gets in the way of the sun, and then we can see its shadow on the Earth. Can we all see the shadow?
Mm-hmm.
Right. And so that's what we call a eclipse. And as you can see, the shadow isn't like on the entirety of the surface of the Earth. It's only on one specific spot. And so that's why you can only see the eclipse on certain spots. And so like as the as the sun's like light moves, like the eclipse, can you see how the eclipse moves a little bit? Right. And so that would be called a lunar eclipse. Or a solar eclipse, sorry. And so solar eclipses only happen when it's a full moon, like how the entirety, right? Is that backwards?
This here is a new moon because this side here is the side here.
Okay, I apologize. So this is
It's important because they made that mistake in Apocalypto.
So this is a lunar eclipse, a solar eclipse on a full moon, a new moon.
New moon. Solar eclipse.
Solar
new
eclipse
moon.
on a new moon. And so when the moon is on the opposite side, this is a
So I'm going to walk back and hold it farther back now.
yes. Okay.
Oh, this is glow in the dark.
So as the moon is on the opposite side of the sun. So beforehand we had the moon and the sun, like how they have the line like this. So like sun, moon, earth. But now it's sun, earth, moon. And this is called a lunar eclipse.
What faces it in right is the moon in right now. Full.
Yes.
Comes over here, and what happened?
Shadow
It fell into shadow of
Yes.
what object?
of the earth.
Sorry.
That's okay. No, you're doing great.
I'm doing great. Excellent.
Okay. Does that make sense, or is it unclear in any way?
Makes sense.
Makes sense.
Does it? Okay.
All right. Excellent. Yeah, let's take this back to- Now, when will the next solar eclipse be?
6 billion years. 21. I don't know.
The first day of school next school year.
Oh.
And where is it going to be visible?
Lincoln. Here.
Right here. Now, we're going to have a celebration. We're going to get some eclipse glasses for you so you can wear them, and we'll make sure classes are not in session at 1 p.m. when it occurs. If you go to the north edge of town, you'll be out of the region that's in full shadow. If you're here, you're just barely in the region that's in full shadow. If you go down to like Beatrice, you'll be in full shadow with full shadow all around you. Now, there's a difference there. If you're in Beatrice, because it's full shadow all around you, it's going to look really, really dark. Here, the edge of town is close enough that you could actually see light from there, so it won't be as dark here. But we will be in complete shadow, which will be very cool. So the first day of school next school year, your knowledge here about how an eclipse works, you can use to amaze your friends.